we're gonna go to Desmos calculator because I'm gonna show you a Fourier series, some Fourier series from Desmos. So let me show you the Fourier series. So the Fourier series is the sum, as in goes from 1 to infinity, of a sub n times sine of pi nx over L plus bn times sine pi nx over L plus a sub 0 divided by 2. So let me show you. So the Fourier series is the sum, as in goes from 0 to infinity, of a sub n times sine of n pi x divided by L. I'm going to show you what L is in a moment. Plus b sub n. Hold up. This is actually cos. B sub n times sine of n pi x divided by L. So L is the period of the function where it's like a periodic function. Visualize it like sine x. It goes up and down, back to 0. From 0 to 1, back to 0 is sine x. From 0 to pi. So the period, which is L, in this point, is pi. So it's divided by the period of the thing, of the function. So the period of cosine of x over 2 is 2 pi. The period of cosine x over 3 is 3 pi. And so on. Same sine x and tangent, but we're not going to get there. So you see that Fourier series? Hold on, I forgot something. A sub 0. Hold on, this is Q. A sub 0. Hold on. A sub 0 divided by 2. Hold up. Divided by 2. And now we need a plus. Hold up. Plus. So that's a Fourier series, right? Let me give you the equation for a sub 0. A sub 0 equals the integral from negative, 1 over L, the integral from negative L to L, f of x dx. You see x in the Fourier series? Here's the formula for that. L is the period. There are a few functions for L equals pi. Well, I'm not going to do that. So, formula for A sub n equals 1 over L, the integral from negative L to L f of x times cos pi and x divided by, guess what, L, with respect to x. That's a Fourier series. A Fourier. Now what about b sub n? B sub n would be 1 over capital L times the integral from negative L. My phone's sideways? Poof. Did I blow your mind? All the way to L times f of x. No, not cos. Sine n pi x divided by L with respect to x. That's very, very good. So now let's graph some functions. Forget that. Let's approximate some Fourier series. So we're going to put the sum as n equals 0 to 50 of sine of x times 2n plus 1 divided by 2n plus 1. Because we can't divide by 0, because 2 times 0 would be 0. Let's listen to that bad boy. I'm using the sound in Desmos, and it makes kind of like a siren sound. We can increase the frequency like that. We could modify it. We could do over n plus 1. We could do over 3n plus 1, which is that. We can modify many factors here. I'm going to do n plus 1 and multiply by 2. That's going to be very good. That's going to be very cool. It's still a Fourier series because the a sub n part of the Fourier series would be 0. And the a0 part would also be 0. And we're multiplying that series by 2. The b sub n would be 1 over n plus 1. Look at that. So that was an introduction to a Fourier series. We're going to do a few more experiments. Sum n equals 1 all the way to 50. This is not exactly the Fourier series, but it's an approximation because Desmos doesn't let us do infinities in sums. Hold up. Cos x times 2n divided by 2n. Since n would be 1, let's do divided by n. Let's make it double the size. We get a triangle-like shape. A right triangle. As this 50 goes to infinity, the triangle gets more and more sophisticated until it perfectly represents a triangle. You see, these are all curves, and they're periodic, they're repetitive. So you can see how there's sine and cosine waves all over this to create a pretty nice approximation. But hold on. If n goes from 1 to 2, we're gonna get a pretty trash approximation. This is garbage. If we go to 5, it's a little bit more accurate. So we need to do this several times for us to get a good approximation. This is 10. It's better. And by 25, it kind of is resembling a triangle. If we go to 50, it's even more accurate. If it goes to infinity, it's going to be perfectly accurate. Let's do another one. The sum, as in, goes from 2 to 50. Sine, the sine of the cosine of nx divided by n 3n plus 4, which let's do this. So it's like kind of like this wavy pattern. Let us hear the sound. Wow. That's pretty much it for today. I will see you later. Wow.